Hello, this chapter is Use Automated Machine Learning in Azure Machine Learning. My name is Tanjun Wen, but you can call me Jordan. I'm a software engineer student, and this program was brought to you by MLSA Malaysia. So, machine learning is the foundation for most artificial intelligence solutions, and the creation of an intelligent solution often begin with the use of machine learning to train a predictive model using historic data that you have collected. Machine learning is a technique that uses mathematics and statistics to create a model that can predict unknown values. We can take this historic data and apply a specific algorithm to figure a function that fits the feature to the label. In other words, the function takes input x to calculate y depends on the number of factors, including the type of model you are using to create and the specific algorithm used to train the model. Additionally, in most cases, the data used to train the machine learning model requires some pre-processing before model training can be performed. Training and deploying an effective machine learning model involves a lot of work, much of time-consuming and resource-intensive. Azure Machine Learning is a cloud-based service that helps simplify some of the tasks and reduce the time it takes to prepare data, train the model, and deploy a predictive service. In the rest of this unit, you'll explore Azure Machine Learning and in particular its automated machine learning capability. To use Azure Machine Learning, you create a workspace in your Azure subscription. You can then use this workspace to manage data, compute resources, code, models, and other artifacts related to your machine learning workloads. This module is one of many that make use of an Azure Machine Learning workspace, including the other modules in the Create No-Code Predictive Model with Azure Machine Learning learning path. If you are using your own Azure subscription, you may consider creating the workspace once and reusing in other modules. Your Azure subscription will be charged a small amount for data storage as long as the Azure Machine Learning workspace exists in your subscription. So we recommend you delete the Azure Machine Learning workspace when it is no longer required. If you don't already have one, follow this step to create a workspace. Sign in to your Azure portal at ms.portal.azure.com using the Microsoft credential associated with your Azure subscription. Select a plus create a resources, search for machine learning, create a machine learning resource with the following settings. So you can choose your subscription and the resource group you can create or select an existing one. And the workspace would also need to be unique, and the region you would choose the region closest to you. Storage account, key vault, application insights, and container registry should be left default. Afterwards, you can click on Review plus Create. After you've created an Azure Machine Learning workspace, you can use it to manage the various assets and resources you need to create machine learning solutions. At its core, Azure Machine Learning is a platform for training and managing machine learning models, for which you need compute on which to run the training process. Compute targets are cloud-based resources on which you can run model training and data exploration process. In Azure Machine Learning Studio, view the compute page under Manage. This is where manage the compute target for your data source activities. There are 4 kinds of compute resource you can create. First of all, compute instance, which is for development workstation that data scientists can use to work with data and models. Secondly, compute cluster, scalable cluster of virtual machine for on-demand processing of experiment code. Thirdly, inference cluster, deployment target for predictive service that use your trained model. Last but not least, attached compute, links to existing Azure compute resource such as virtual machine or Azure Databricks clusters. Once the resources has been deployed, you can either go to resource, or if you are at the dashboard, you could locate your resource, which is type machine learning. Click on it, launch the Azure Machine Learning Studio, and then go to the Compute Instance tab and create a new compute instance. The virtual machine name, you can give it whatever you like. I will leave it to default. Virtual machine type to CPU. Virtual machine size to all option. And then search for standard underscore DS11 underscore V2. So this is it. And then click on create. So while waiting, let's go to compute cluster and then create a new compute cluster. Give the location nearest to you. Virtual machine priority, give it dedicated. And then virtual machine type, CPU. Virtual machine size, choose select from all, same as before. And then search for standard underscore DS11 underscore V2. There it is. Click on next. And then a compute name, give it a unique name. Minimum number of nodes 0, maximum 2. And idle second, set it to 120. Make sure you unselect this, enable SSH access. Click on create. And voila! You have one compute instance and one compute cluster. Machine learning models must be trained with existing data. In Azure Machine Learning, data for model training and other operations is usually encapsulated in an object called a dataset. So for the dataset, we'll be using historical bicycle rental details, and you can go to this website aka.ms/bike-rental to view the comma-separated data. Save this as a local file named daily-bike-share.csv. And in Machine Learning Studio, view the dataset page and create a new dataset. Select local file, give your dataset a name, dataset type tabular, description bicycle rental data. Click on next and locate where you have downloaded your file. And there is my file. Click on next. In settings in preview, we should mention that only first file has header. Click on next, review and confirm. Azure Machine Learning includes an automated machine learning capability that leverages the scalability of cloud compute to automatically try multiple pre-processing technique and model training algorithm in parallel to find the best performing supervised machine learning model for your data. But take note, the automated machine learning capability in Azure Machine Learning support supervised machine learning models. And in other words, models for which the training data includes no label value. You can use automated machine learning to train models for classification, regression, and time series forecasting. In the Azure Machine Learning Studio, view the automated ML, create a new ML run, select a dataset, click on next, give your experiment name, target by column, which is the X, to figure out the Y, that means the result. Select a compute cluster, the compute cluster that you've created earlier, click on next, and the task would be regression, and let it run. After you've used automated machine learning to train some models, you can deploy the best performing model as a service for client application to use. Alright, after 47 minutes of running, nearly 50 minutes, it's been a long run. We can see that there is a best model summary that has been trained, which is called voting ensemble. And we can go to the automated ML page, select the run, then on the model tab, use the deploy button to deploy the model. So we should give our model a name and just a simple description. Compute type, give it Azure Container Instance and enable authentication. So once done, click on deploy, wait for the deployment to start. Hooray! Our model has been deployed as a service, and we could go to endpoint and see that our service has been deployed. So next, we should select on predict rental, then select the consume, and there's the information we needed. Thank you, and that's all my presentation.